Hi there. A researcher believes that the annual income of male graduates from law school is higher than that of female law graduates. He randomly selected 30 male graduates, X, and 30 female graduates, Y, from different law schools in the country. Their first year's income, X dollars and Y dollars to the nearest dollar, is summarized in this table. And here's the table: total income for the first year, summation of X and summation of Y. Male is 796,470, whereas female is going to be 774,390. The total income squared in the first year is summation of X squared is equal to all of that big figure over here. Summation of Y squared is equal to all of this here. We need to calculate a 90% confidence interval for the difference between the male and female law graduates' average incomes in their first year, and then also comment on the 90% confidence interval. So the information that I have is that summation of X is equal to 796,470. Summation of X squared is 212, 284, 403.30. And for the females, summation of Y is equal to 774,390. And over here, we've got summation of Y squared as this figure over here. Right, so let's try to get this into the camera here. There we go. And now the first thing that I've noticed is that the population variance is unknown, and that this n is fairly large, 30. So that means we're going to use a normal distribution. I'm going to approximate a normal distribution, reason being, as I said, that sample size is very large and the population variance is unknown, so we need to calculate that. So first thing, what I will do is I'm going to use a sample value. Let's see here. So we want to find the Z distribution, the Z values, basically. This is a 90% confidence interval. Over here, it's going to be 0.05. Same goes for the right-hand side. And if we were to work this from a table, statistical table, these would be the values of Z, which is plus or minus 1.645. And basically, now we want to find the mean of X. Okay, so the mean of X means the average income of males. So average income of males. That is very simple. So 796,470 divided by 30. Do this on the calculator, you're bound to get 26,549. And same goes for the average income of females, which is summation of Y, 774,390, all of that over 30 comes to 25,813. So the next thing I want to do is I want to find the unbiased estimate of the male and female population variances. So an unbiased estimate of the male population variance is going to be, we're going to be using the formula 1 over n minus 1 into summation of X squared minus summation of X whole squared, and then divided by n. So for the males, unbiased estimate of the male population variance, I'm going to get 1 over 29, because 30 minus 1 is 29, into 212, 284, 403.30 minus 796,470 to the square over 30, and the unbiased estimate of the male population variance is 2,860,631. And as for the females, again it's 1 over 29 into 200,761, 179.90 minus 774, 390 all squared over 30. And that comes to 4,567,838. So the next thing is we're going to be using this formula, which is the confidence interval for the difference of two population mean. This is confidence interval for the difference of two population means. Of two populations. Okay, population mean. So all we need to do is then just substitute the values into this formula. And if we do so, we're going to take, then this is going to give the mean of both here, the mean of x1 minus the mean of x2, which is the mean of the male minus the mean of the female income, plus or minus the z value times the square root of the standard deviation of each one of them over their sample sizes, and the sum of that into that square root, and this is the figure that you reach. And therefore this is going to give us 8.38, which is less than the mean of x minus the mean of y, and basically less than or equal to 1,461.62. Or simply, we're going to put it like this. That's our confidence interval, 8.38, and then 1,461.62. So to the nearest dollar, the 90% confidence interval, to the nearest dollar, okay, is going to be between males and female law graduates. Okay, we can say the confidence interval for, okay, the difference, all right, in the first year, okay, in the first year average income between male and female law graduates is $8 to $1,462. Okay, so this is what we have in terms of the difference between the male and female law graduates when it comes to their income. And so for my comments, okay, I am over here 90% confident that, okay, the difference in the average, the difference in the average income for the first year, male and female graduates, okay, is between $8 and $1,462. Now, in this particular example here, there is a statistically significant difference, okay? You can say there is a statistically significant difference, okay, in the first year average wage male, in the first year average, okay, wage between male and female, okay, because the 90% confidence interval does not contain the value 0. And also, this 90% confidence interval for the average first year income is quite wide. This is quite wide, and which is due to the large estimated variances. Okay, for both male and female graduates. So here we are for this question. I hope you've been able to get some understanding of how we go about and calculate the population, the difference between the population mean, okay, for type of gender over here. And if you like this video, please don't forget to like and subscribe and share as well. Take care.